Welcome to a new lesson. Before we start this lesson, let's review some exponential laws. There are three. The first law is when we multiply the same bases together. That means, for example, when we multiply three bases together, let's look at the example below, the 3's are the bases and the exponents are 2 and a 5. We add the exponents together. So 3 base 2 plus 5 is 3 to the power of 7. For the quotient power laws, let's look at the last example. When the bases are the same, the base is negative 5, the exponents subtract. So 10 minus 8 will give us negative 5 to the power of 2, which is in this case 25. When we have powers of powers, that means we have brackets and we have doubled exponents. We multiply the exponents together. So that means 2 times 5. So it's 4 to the power of 2 times 5, which is 10. These are three laws that are very important for you to know. And please memorize them if you do not know them by now. We're going to use these laws to help us understand the following lesson. In this lesson, we're going to talk about fractional exponents and radicals. Before we start these examples, let's talk about the understanding of fractional exponents. So what does this implicate? The A is considered a base. And when we have a fractional exponent, the n will identify with the index of the exponent. Pardon me, the index of the radical. So the n becomes the index, and A becomes the radicand. So with A, 27 to the power of a third, 27 will become the radicand, while the 3, the denominator of this fraction, becomes the index of the radical. Using this idea, let us rewrite all of the powers. So we have 0.49, the base, is the radicand, and since the fraction is 2, the index is 2. For part C, we have negative 64. It becomes the radicand. We have a square root. Not a square root, but because the denominator is 3, it becomes a cube root. And for fractions, we can split the fractions into powers on their own. So this means that we're going to have a square root of 4 and a square root for 9. Now we could solve all of these using previous lessons skills. So the first answer is 3, because 3 times 3 cubed is 27. 0.49 squared root is 0.7. For C, we can do this 64 by prime factorization, and you realize there are 6 2's. The index is 3, that means we're using groups of 3. From each group we'll collect one of the individual units, which is 2, and we multiply, which is 4. What else is missing is the answer cannot be 4, because 4 cubed is 64, and our answer is negative 64. In this case, we'll add the value of negative, or the sign of negative, to our answer to make sure that it comes back to negative 64. And for part D, it's just square root of 4 is 2, and the square root of 9 is 3. So 2/3 is our answer. Let's take a look at a different example. We're going to rewrite these powers as a radical form. So let's take a look at 40 to the power of 2/3 first. There are two ways to rewrite this 40. We always know that 40 is the radical under the radical sign, or it's called radicand again. The 3 is the denominator. It becomes the index. What happens to this 2? The 2 becomes the power of it. That means we can either put the exponent 2 outside the bracket for the entire radical, or, which is the same thing, we can recopy the radical 40, the index 3, but now put this square inside the radical with the 40. It does not make a difference. Both of these are correct. Let's continue with part B. Root 3 to the power 5. We want to change it to exponent form. Now exponent form is, I'm just going to circle the exponent. This is the exponent form. There's no radical signs. So let's do it. Again, identify what the index is. The index is 2. And the power of the 3 was the 5. Pardon me, the 5. So the base is 3. So the radical is radicand 3, so that's our base. It has a fraction of 5 over 2. That's the exponent. And let's continue on with root 25 with the radical index of 3 and power of 2. For good practice, I'm going to just change the color so you can see a little bit better. Again, the radicand becomes the base of the power, and the 2 becomes the numerator of the exponent, and the 3 becomes the denominator of the exponent. So now we are just rewriting the expression into either exponential form or radical form. Let's take a look at an example. In this case, I'm going to evaluate without a calculator. And we're going to use the calculator just to verify our answer. So whenever we have exponents like these, it is a good practice to rewrite them in a radical form. So when we write this in a radical form, now I'm not going to use the colors. Again, the 3 is the power, the 2 is the index. So what is the square root of 0.4? Square root of 0.4 is 0.2. And don't forget the power of 3. And the cube of 0.2 is 0.008. And without the calculator, this is the reasoning behind it. We have 1 decimal point, and since the exponent is 3, this will change to 3 decimal point answer. And what is 2 to the power 2 times 2 times 2? Well, that is 8. So we have to rewrite the 8 into 3 decimals. Therefore, this is your answer. You can check this on your calculator by typing the following: 0.04, and you're going to find this little hat, and put a bracket, type in 3 divided by 2, and you will get the answer of 0.008. Let's do part B now. Again, we'll rewrite this into a radical form. Identify that the index is 3, and everything's going to be multiplied, or pardon me, everything will be exponential to 4. So cube root of 27 is 3, and then we're going to take the 3 to the power of 4, which is 3 times 3 times 3 times 3. And that answer is 81. And for your calculator, type in 27, again using the start a bracket, 4 divided by 3, close the bracket, and you will get 81. Part C now. Negative 32 to the power of 0.4. Now 0.4 is a decimal value. Or, in other words, because there's one decimal point, it is 4 divided by 10, which can be reduced to 2/5. How do we reduce? We divide the numerator and the denominator by 2. Therefore, we could rewrite negative 32 to the power of 2 over 5, which is, in radical form, 32, index of 5, and everything to the power of 2. Negative 32 to the radical of 5 is negative 2 itself. And negative 2 to the power of 2 is 4. For part D, we're going to use a similar method as we did in part C. First of all, 1.8 to the power of 1.4 is the same thing as 14 over 10. Which can be reduced further by dividing by 2 to 1.8 to the power of 7 over 5. The moment you see a decimal like this, that is greater than 1, it is very difficult to find or to know the roots and use the exponentials without the use of a calculator. So we're going to use just our calculator. And therefore, we didn't even have to reduce to 7/5. On your calculator, 1.8 hat bracket 1.4 will result in the answer of 2.27. And of course, it goes on forever because it's an irrational number. Let's take a look at some application examples. In this example, biologists use the formula B equals 0.01 meters to the power of 2/3 to estimate the brain mass, B, in kilograms, of a mammal with body mass M in kilograms. Estimate the brain mass of each mammal: a husky with a body mass of 27 kilograms, and then a polar bear with a mass of 200 kilograms. So what the question is asking, using this formula, we are going to be estimating the brain mass of a husky and a polar bear. So let's use this formula to find the masses. So B for part A is 0.01. I'm going to sub in the mass value of the husky, which is 27 kilograms, to the power of 2/3. It's a good idea to try to solve problems without using the calculator. So we're going to rewrite the 27 into our radical. So 27, the index is 3, and we're going to square it. So B is 0.01 times the cube root of 27 is 3 to the power of 2. So B is 0.01. 3 times 3 or 3 squared is 9. And 9 times 0.01 is 0.09 kilograms. So that is the mass of a husky brain. We're going to use the same method to find the size of the brain for a polar bear. So I'm going to plug in the value for m for a polar bear, which is 200, to the power of 2/3. And now we're going to use the calculator because it's very difficult to reduce 200 to find the answer for the mass of the brain mass of a polar bear. So for your calculator, 0.01 times 200 little hat bracket 2/3 will give me the value of 0.34 kilograms. So notice the size of the brain of a mammal is small in comparison to the rest of the body.